Hello, welcome to the Dev Summit. My name is Ming Zhao, and this is my colleague, Kwesi Asante. And we're both Java developers on the GeoEvent team. And today we're going to give a talk about creating custom connectors and processors using the GeoEvent SDK. So this is our agenda today, and we're going to get a high-level view of the product. And then we're going to talk about connectors, transports, and adapters. And then Kwesi will take over and talk about processors and what's common in all these extendable components. And then we'll summarize the presentation. So let's talk about the GeoEvent at a high level. The GeoEvent gives the ArcGIS server the ability to integrate real-time data into ArcGIS infrastructure. If you have attended other GeoEvent sessions, you probably will be familiar with this slide. So it ingests high volume and high velocity data from connected devices, sensors, and other IoT service layers. And then it also provides streaming and analytics of that data while in transit. And then it introduced a big data storage solution to support the volume of data being received. And it extends the visualization capability of ArcGIS Enterprise through the stream layers. And finally, it disseminates and actuates the data back to devices or service layers. So GeoEvent receives real-time data using the inputs that are defined by input connectors. So out of the box, we have input connectors that receive or pull data in RSS, text, JSON, or feature JSON formats from sources like TCP or UDP sockets, REST endpoints, web sockets, or ArcGIS servers. And we also have the capability of monitoring files in folders. So in addition to these connectors, we also have a list of input connectors that are hosted on the Esri gallery and the partner galleries. So before you develop your own connectors, you should always check with these sites and see if someone already developed something that may meet your needs. So we have mentioned that inputs are defined by input connectors. So what is an input connector? An input connector is a combination of a transport and an adapter. We'll explore these components in great detail in the first half of this presentation. This slide illustrates how we can create a connector using available transports and adapters. So for example, the receive feature JSON from a Kafka connector is composed of a Kafka inbound transport and a feature JSON inbound adapter. And the receive GeoJSON on the REST endpoint connector is composed of an HTTP transport and a GeoJSON adapter. So it is important to note that you can create a new connector that isn't part of the core offering by combining the existing transports and adapters. You can do all that on the GeoEvent Manager UI without writing any custom code. So the outbound connectors handle similar flavors of data as the inbound connectors, such as JSON, text over TCP, UDP, REST, or WebSocket. It has additional options, such as sending out emails and text messages. And most importantly, the ability to send GeoEvents to a spatial temporal big data store and a stream service. So there are also additional connectors on Esri and the partner galleries. So similar to inputs, outputs are defined by output connectors. An output connector is again made up of an adapter and a transport. So for example, the send an email output connector is composed of a message formatter adapter and an SMTP transport. And the publish feature JSON to Kafka connector is composed of a feature JSON outbound adapter and a Kafka outbound transport. This slide also lists all the available outbound adapters and outbound transports that are out of box and from the galleries. Then when the data is acquired, then we can apply real-time analytics to the data, which allows you to filter and process the data. So Kwesi will get into the details of processors in the second half of this presentation. So this slide summarizes where you can add your own code to GeoEvent Server. You can customize inbound and outbound connectors. You can also customize processors. The GeoEvent Server comes with an SDK, which allows you to build custom connectors and custom processors. The SDK provides a number of resources to accomplish these tasks. You can see a snapshot of the folders here that are delivered along with the product. When you install the product, you'll have this SDK folder. The SDK folder contains an API folder, which is the Java doc that describes the API. It also contains a repository folder that contains a set of libraries that you can use to compile against when you develop the custom code. The samples folder contains 12 sample projects for adapters, transports, and processors. They are updated for each release, reflecting changes that are made to SDK in each release, if there is any. So the developer guide describes the software architecture, how to work with GeoEvents and GeoEvent definitions, and how to use Eclipse to write and debug the components. It also describes in detail what the takeaways are for these samples. So now let's dive into connectors. A connector functionally provides the user the ability to create inputs and outputs. Its purpose is to hide technical details the end users don't have to care about. It can be very specific, for example, getting the latest earthquakes from a USGS RSS feed, or it could be very general, like getting any type of RSS feed. So here is how it works from a high level. The user wants to connect the GeoEvent to a number of feeds on the internet, such as the National Weather Service, the USGS, and live traffic. He looks at the list of available inbound connectors. He sees a receive RSS connector, a pull external website for JSON connector, and a receive text from a TCP connector. So he sees that the National Weather Service provides an RSS feed. So he uses the receive RSS connector to create an input called storms, which connects and receives data from the National Weather Service. Then he looks at the USGS site and sees that they have an RSS feed as well. So he is going to use the same connector to create a second input called earthquakes, which consumes data from a USGS RSS feed. So there are two separate inputs using the same underlying logic to consume data. Now he looks at the live traffic service and sees that they provide content in JSON format over the web page. So he uses the pull external website for JSON connector to create a third input called traffic to receive data from the live traffic service. So the user is done with creating the inputs, and the inputs are continuously receiving data from these sources. The connector can help the user through these configurations. It can provide default values for properties. So in this case, instead of calling instead of a generic input name, you can provide a more meaningful default input name when you configure a connector. You can also provide default values for the properties, such as the URL and the frequency in this case. It allows you to relabel the properties. So instead of calling a property URL, which may not be very specific to users, you can rename it to something like RSS address. And you can move properties to different categories. So for example, the frequency property, if the user doesn't have to change it, then you can move it under the advanced category. The properties under advanced categories category don't show up by default. You have to click on the advanced button and then they will show up. And then you can also put properties that the user never have to change into the hidden category. So in this case, for example, the URL proxy, if the user will never change that, then you can just put it in the hidden category and it will never show up on the UI. Now let's dive deeper into connectors. So functionally, when a user selects a connector, he implicitly selects the component inside the GeoEvent server that knows how to receive and send data. We call that component transport. and the component that knows what the data looks like. We call that component adapter. With that knowledge, the adapter can convert raw data into GeoEvent and from GeoEvent to raw data. So here's an example of an input. It is created with a connector which specifies a TCP transport and a text adapter. So the input uses these components by starting the transport, and while the transport is running, it would produce a stream of bytes, which the input then passes to the adapter for parsing. And then the adapter produces GeoEvents, which the input then sends out to all the different services that are created to make use of that stream of data. Now let's take a look at a connector from the GeoEvent Manager UI. So this is the Manager UI. In order to create an input, you need to click on this input button, add input button, and then you'll be presented with a list of inbound connectors. You use an inbound connector to create an input. So where do you find all these out-of-box inbound connectors? So let's go to the site page. And we have a list of connectors here. If you click at the connectors on the left-hand side. So these are all the out-of-the-box connectors. So all these are out-of-the-box connectors. You can not edit them. You cannot remove them. But you can look at them, and you can also duplicate them. So we can also filter the connectors from this drop-down box. We can list, for example, all the inbound connectors. So let's take a look at a connector. The connector, a connector has some attributes such as name, label, and descriptions. And a connector could be an inbound connector or an outbound connector. In this case, I selected an inbound connector. And once you select the input here, it will give you a list of inbound adapters in this dropdown, and also a list of inbound transports in this transport dropdown. And you will select a adapter and a transport. Another thing you will need to do is to give it a default input name. So you will create an input with this connector, and that will be the input name for the input that you created if you don't change it. So when you first selected adapters and transport, an adapter and a transport, all of their properties are listed here under shown properties initially. And what you can do is you can select some of those properties and use these buttons to move them to advanced category or the hidden category. Another thing you can do is to move a property up and down and to resequence them. And you can also double-click on a property, and you can change its default label, or you can change its default value. So when you're done, you can click on the Save button to save your changes, or the Create button to create a new custom connector. So you don't always have to write custom code to create a custom connector. So out of the box, we have a number of adapters and number of transports, but we don't have connectors that cover all of those combinations. So if you have a need for a special combination that we don't cover, then you'll you will come here and create your own custom connector. And also, sometimes you want to highly customize your connector. You may want to set different default labels and set different default values. And in that case, you will come here too to customize a connector. All right. So now let's talk about transports. So we have mentioned the transports and adapters when we describe connectors. So let's take a look at what a transport does. Its basic function is simply to move data in and out of the GeoEvent server. Programmatically, it has three basic pieces. The transport definition. This is the class which provides metadata and the properties of the transport. The transport itself that contains the application logic, such as subscribing to an MQTT broker for messages or reading files from a folder. And then transport service. This is the hook into everything else. The GeoEvent server first defines the transport service. It asks for the reference of the definition so it can present properties to the user interface. When the user clicks on the save button on the input or output page, then GeoEvent server asks the service to create an instance of the transport. So you can view the transport service as the gateway to the metadata and the properties of the transport, and a factory to new instances of the transport. And you will see this same design pattern repeated for adapters and the processors later on in the slides. And we will point out again what is common among all these extendable components before the end of the presentation. So transport behavior is not the same as the behaviors of other components. So inbound transport receives the user configured properties from the GeoEvent server. It also receives the byte listener, which is a Java interface from the server. It uses the interface to push data to adapter for parsing. And inbound transport is started and stopped by the server. When it's started, it sends data to the server. When it's stopped, it stops sending data. Transport has 5 states in its life cycle. This is also unique to transports. It starts out in a stopped state. When the user starts the input, the transport goes into starting state. It initializes resources, such as socket connections, opening socket connections, and reading the file systems. After resources are initialized, it goes into started state and stays there until something happens, such as the user issues stop request. Then it goes into stopping state and it closes all the resources, then the stopped state. When error occurs, it goes into an error state, and then the server can ask the transporter, which, via the interfaces of what caused the problem. Outbound transports are just like inbound transports, but in reverse. They get started, but instead of producing bytes, they are sent bytes repeatedly, and their job is to push these bytes to an outbound output destination. The outbound transport also has the ability to take a peek at the GeoEvent it's sending. So this allows the transport to dynamically determine how to send the event. So before we get into the actual code of a sample transport, let's go over the concept of component definition class and the property definitions. These concepts are common to all adapters, transports, and the processors. So a definition class contains a list of attributes for the component and a list of property definitions. The component attributes describe the component, while the property definitions tell the component how to do its job. The component definition can be created either through XML or a Java class. This slide shows an example of XML-based component definition. It starts with the attributes for the component. This includes name, label, contact, domain, version, type, and description. The label and description are localized. Then there is a list of properties that the user can set to define the component behavior. The property definitions have their own attributes, such as name, label, description, property type, property default value, and so on. Property labels are what shows up for each property on the manager UI. And property descriptions show up when you click on the question mark next to the property input box. So both of them are also localized. So this slide shows the syntax of using localized strings in XML. When GeoEvent Server sees the $ curly bracket notation in the XML or a Java class, it will attempt to replace the string with the localized string from the corresponding localized properties file. So which properties file it uses depends on what's inside the curly bracket and the locale. So inside the curly bracket, we first have the Maven group ID of the component, which will match the folder structure of the properties file in the resources folder. And then we have the Maven artifact ID, which corresponds to the property file name. And finally, we have the key of the localized string, all in uppercase. And GeoEvent Server will use these information along with the locale of the server to find the localized strings to replace the $ curly bracket notation. So there are a few other functions that can be achieved through the properties. One of the things the properties can do is to set itself to be a mandatory or optional, and properties can be dependent on other properties. So in this case, one property lets the user decide whether to compress the data or not. If the user chooses yes, then the compression algorithm property shows up. Otherwise, the compression algorithm property disappears. And some properties can have predefined values. In this case, 3 predefined compression algorithms are presented to the user so that the user can choose one rather than entering one manually. So here's another way to define properties in a Java class. This code snippet shows how we could create a property definition with allowed values in Java class. So continuing with the example on the previous slide, we have a list of allowed values for compression algorithm. And each has a label, which can be localized, and a value. We pass this list of allowed values in when we create the new property. So now let's examine a custom transport. For the background information, the transport we are going to look at is the MQTT for GeoEvent Transport, and it is publicly available on the GitHub. And MQTT is a protocol that is mostly popular with IoT applications because of its high efficiency, scalability, and a low requirement for bandwidth. All right. So I downloaded this project from GitHub, and initially you'll see a parent folder, and under the parent folder you'll have a sub-module. In this case, it's MQTT transport. And the reason we organize the folders this way is because sometimes when you download a custom transport, you will have both a custom. When you download a custom connector, you will have both a custom transport and a custom adapter. So let's take a look at the POM file of the parent folder. So here we have a group ID and artifact ID for the parent, and then we have some properties that sets the version numbers for dependencies, and then here we specify the submodule. And in this case, we only have one submodule, which is the MQTT transport. And then we list all the dependencies that are common to all the submodules. And usually we will put the GeoEvent SDK and JUnit test libraries here. And now let's take a look at the POM file of the submodule. So we have the group ID here, which is com.esri.geoevent.transport. We're going to come back to this when we talk about localization. And then the artifact ID, which is the MQTT transport. And here we list, under the dependencies, we list only the dependencies that are needed for this submodule. So now let's take a look at the code. And we can see that this custom transport has both an inbound transport and an outbound transport. So let's take a look at the inbound transport service. The MQTT inbound transport service extends the transport service base class. And when you create a new transport service, you'll also extend this base class. And in the constructor, it basically loads the definition class from the XML. And when the create transport method is called, it creates a new instance of the MQTT inbound transport with the definitions. So now let's take a look at the definition. In this case, the definition classes are written in XML. So as we mentioned before, we have a list of attributes that describe the component. And then we have a list of property definitions that will tell how this component, how to connect it to the MQTT server, MQTT broker and what topic to listen to. So these are the properties. And as you can see that the quality of service, QoS property has a list of allowed values. And also another thing I want to point out is the property type. And in this case, most of them are strings, but we have a password property, and its type is password. So the password you type on the browser will not be displayed. So let's take a look at the transport. So in this case, the MQTT inbound transport extends inbound transport base. When you create a new custom transporter, you also extend this inbound transport base class. And in this case, it also implements the runnable interface. So it's going to implement the functions of a thread. So it first creates a bundle logger, and we use that to log error messages or info or warning messages. And then in the start method, we first set the running state to starting, and then it starts the thread. So when the thread starts, it calls the run method, and then it calls the receive data method. In the receive data method, it first calls the apply properties method, and this is where the transporter loads all the custom user configurations. And then it changes the running state to started. And then all of these things are the business logic related to this custom transport. In this case, it creates a new MQTT client, and it sets the callback class, and then it connects the MQTT client, and it subscribes to the topic that the user defined. So when the data arrives, the message arrived method is called, and all it's doing is passing the payload of the message to the receive method. So if we go to the receive method, we can see that it receives an array of bytes, and then it converts it to byte buffer, and then it calls the byte listener .receive method to push the byte buffer to the adapters. So here in this code, we can see that the log message, the log methods like error and info or warning. So when we call the bundle logger method, we don't really need to supply the group ID and the artifact ID like we saw earlier, because the bundle logger knows exactly what the group ID and the artifact ID is for this component. So where are the localized property files? So they are under the resources folder. So under resources folder, we have a COM folder, and under the COM folder, we have Esri, and then GeoEvent, and transport. So this folder structure matches the group ID. And then we have a properties file under the name of MQTT transport. And this properties file has the MQTT transport, under dash transport is the artifact ID, and this property file also has the locale in it. So if the server is in this locale, then this properties file will be used. If the server is in a locale that didn't have any matching property files, then this property file will be used as default. So if we take a look at the properties file, and we see a list of key value pairs. The keys are all in uppercase. These are the keys to the localized string, and the values are the localized string. So in this case, it's EN/US, so we see all of them in English. If it's a different language, then this will be translated. So now, after you finish editing the transport, the component, then we can start to build it. So you will go to the folder that you downloaded from GitHub, and it's the parent folder that you can go to, and you can just issue an nvn clean install method to build the jar file. So once it finishes building, build successful. So once it finishes building, then it will generate a jar file in the target folder of the submodule. So let's go to the submodule, which is MQTT-transport. And if we look at the submodule, we have a folder called target here. If we go to target, and we see this jar file, MQTT-transport version.jar. And to install this component, you'll copy this jar file and paste it into the deploy folder of the GeoEvent install folder, under the GeoEvent install folder. That's how you install a component. Okay, so let me go back to the slides. So let's talk about adapters. So similar to transports, an adapter is packaged as a jar file with several classes in it. The adapter has a definition just like a transport does, which provides metadata and properties of the adapter. It also contains the functional code, which is the adapter in this case. The adapter implements the application logic. And there is the service, the adapter service in this case. Just like the transport service, it consumes the definitions and serves as a factory for instances of the adapter. The behavior of adapters is different from that of other components. It has properties like transport and has a listener which can send results to, but instead of listening for bytes, this listener listens for GeoEvents because inbound adapters convert bytes to GeoEvents. And another significant difference is that the adapter is data-driven. It does not get started or stopped by the server. But whenever data is sent to the adapter uses its special knowledge about the data to convert the data to GeoEvents. So let's walk through a sample adapter that converts fixed format binary data to GeoEvent. The incoming binary data contains an integer which we want to use as the track ID, and it also contains two double for the longitude and the latitude. We want to convert this data into a simple GeoEvent that contains a track ID and a geometry field. So the code here is a Java class that defines the adapter definition and the properties. First, in the constructor of this definition class, it creates a GeoEvent definition. So as we know, each GeoEvent must have a GeoEvent definition. The GeoEvent definition defines the field, their types, and cardinalities. Because the adapter has the knowledge of what the data looks like, it is naturally the component that creates GeoEvent definition. But we don't always have to create a new GeoEvent definition when we create a new adapter definition. You can use an existing GeoEvent definition or have the user pick a GeoEvent definition through the property configuration. So in addition to creating the GeoEvent definition, the adapter definition class also defines the same GeoEvent, same attributes about the adapter as we saw in the transport definition, such as name, label, description. And here is the adapt method of the adapter class. As we mentioned earlier, the data we want this adapter to parse is a piece of binary data which contains an integer and the two double numbers. The integer will be used as a track ID and the two doubles are longitude and latitude. So when the adapt method is called, a byte buffer is passed to the adapter. The adapter then uses its knowledge of the data to get the track ID and the X and Y fields from the byte buffer. Then it creates a new GeoEvent using the GeoEvent definition that was defined in the property definitions class. It then sets each field of the GeoEvent, and then the geometry field is set to a new map geometry object created from a point and a default spatial reference. And finally, it returns the GeoEvent. So I also highlighted the geometry creation to show what you could expect from a geometry field in GeoEvent, as well as a couple of bundled logger methods to show how you can use localized strings with bundled logger. So with that, I'm going to turn it over to Crazy for more details on processors.
All right. Thanks, Ming, for that quite comprehensive overview of connectors. So now we've had a good idea of bringing data in from external sources. Oh, that's not cool. Okay, this is mine.
Yeah,
switch. Okay, let me make sure I can
do a Commando F1.
Well, let me see. I think it stayed on too long, and so it might have. All right, cool. All right. So let me try to reboot on that one. So now we've had a good idea of bringing our data from all the other various sources that we have, right? We have all these sensors in the field to bring our data in through the implementations of the transports and the adapters. So the byte array comes, when we adapt them, we create a GeoEvents. Now, the processors or the processing part of the whole workflow is where you add the value. You add the analytics or you add the signs of wear to it. So that's what we're going to talk about here. Now, what I'm going to try to do during the last part of this presentation is that I'm not going to try to go so much into detail in some of the parts that are kind of key or similar to what Meng talked about, but I kind of make allusions to that, and then during the session where we talk about the similarities, I'll kind of point them out. So we have some of these processors that are some out of the box, and we have different versions and different ones doing different stuff. Some are processes that you can create on your own, like the ones in the gallery. And as a matter of fact, during the next release of 10.7, we actually brought some of these galleries items, and we rewrote everything to try to make them out of the box for you. So if you're used to using some of these gallery items and you find them in 10.7, they're not exactly the same, but they do work in a similar manner. So if you want to basically try to do one-to-one from what your workflow is, you might want to reconsider some of the configurations before you try to use them. So your processor. So the processor part of it is part of the whole extensibility story, right? Where GeoEvent can be customized to create business logic that we didn't think about, or we could possibly think about what you're doing. So when you have this, the SDK gives you that opportunity to actually extend the story of processing that meets your business need. So let's take a look at the processor lifecycle itself. So we're going to try to review this by looking at the processor component, by following how the service, GeoEvent service is published and starts in the first place. So here, a user will submit a publish or start a new service request. And this is actually done in the GeoEvent Manager window. And some other presentation, you actually have a good idea of how everything going, because they actually go through everything to the UI. And so for every processor configuration for GeoEvent processor, the GeoEvent actually looks up the processor service in an internal registry of ready-to-use components. So the container itself does have some ready-to-use component that are actually registered, and then passes the user-defined configurations to initialize it. So there are certain lifecycle stuff that actually go through that. This is the creation stage. Now, when you start with that, we move on to the initialization stage. After the creation stage is actually done, you move on to the initialization, where the provided information is actually used to initialize the method. And then the next is to call the validation method, or the validate method. And that validate method brings you to the validation stage of that. And this is another life cycle. And the next part, which is basically, let me backtrack there. The next part is basically the processing part, right? This is where the meat of the entire stuff happens. This is where you want to actually do your business logic. You want to add the stuff that we didn't think about, or stuff that we have thought about, and even if we're doing the processing, we are the one, we're bringing in the business logic itself. This is where stuff happens. Right after that, you can go to the shutdown mode after the processing has happened, because sometimes your data stream is bounded, right? Sometimes it's unbounded. In the cases where it's unbounded, you stay in the processing stage and keep going and do the processing. But if it's a point where you need to shut down, you want to shut down the service, you go ahead and then get to that stage. So that is that. Now let's take a look at the anatomy of the processor itself. As you can see, most of these, or it's quite similar to some of the stuff that Ming talked about during the connectors part. So I'm going to skip this a little bit more. We'll come back to some of them in the later slides, and we'll talk a bit more about it. Now, if you look carefully, the only difference that Ming didn't talk about there is the configuration part, but that is a little bit of a detailed slide that I have later on that I want to talk about. So let's move on to that without further ado. So now we have everything set up. We've gone through the entire understanding. So what we're going to basically do, go over the service GeoEvent service uses, what GeoEvent service actually uses to create a processor, right? So first, you just create a normal Java class. That class implements the GeoEvent processor service, right? So this is the service that is the interface in our API that you want to extend. Now, that service itself, you could actually use the base class, and this base class is called the GeoEvent Service Processor, GeoEvent Processor Service Base. And if you're looking at how the naming conventions is actually done, you actually start to see some patterns actually going on here. During Ming's presentation, you saw all those base classes, right? So you see an interface name come in and a base, kind of naming comes, and then the base is basically going to tell you that that is a base class implementation that we've already done. It's part of the API. You don't need to actually implement it, interface yourself to try to use some of these. You can actually go ahead and use some of the methods. So if you don't need to override certain methods that actually fit your own business need, there's no need for you to implement that interface. Just go ahead and use the ones that we already have built for you in the out of the box. So every service is actually responsible for providing its own definition, right? The definition itself is what Ming talked about, and that is what is giving you the implementer or the programmer an ability to get what the user is actually bringing in, right? So the various parameters that the user is actually going to provide, or the information that you need from the user to be able to do the processing, right? So that is where you actually you do to actually get an instance of all the configuration parameters that are there. That is the definition object itself. And then you go ahead and you create an instance of the GeoEvent service. So this is an example of a demo project that I actually wrote for this presentation. The code is actually it's all available on GitHub, so right after this presentation, we'll give you the link to look at it. I intentionally left a bug in there just so we can actually use it as a test project to actually try to debug and learn how to do that. Maybe later on I'll try to fix it, but if you find more bugs in there, you can log an issue and I'll try to fix it later. I encourage you to take a look at the processor itself, download it, clone the repo, try to go through everything, just like Min did with the MQTT. There are other ones as well. It helps you kind of understand beyond just this presentation what is actually going on under the hood. Okay. So if you look at it here, those are the things that I talked about. It extends the base class, and then kind of does all the other instantiation. Now, if you look at it here, it does do the instantiation in the constructor itself. So we have an instantiated reference to the definition. The definition object or the definition reference itself is a super member of the GeoEvent service base class itself. So once you have that, now you can actually use that to actually do the creation of the GeoEvent processor. Remember, we talked about the processor, we talked about the definition, and we talked about the service. Let's go on to look at the definition itself. So in this case, this is just a simple definition that I have in this demo processor. It's just getting one parameter, right? It gets just one time window parameter from the user and says what is the time window that you want. You give it an integer value and that's it. So those two values there, that the Maven localized string over there is just a way to actually give you the label itself and then the description, so the user knows what they're actually supposed to provide. And then the constructor itself is a way is the location we try to populate the processor, the property definition reference, which we get as a super member of the GeoEvent definition base class. Like I said, these are all classes that have actually been used in the API, so we encourage you to use it. If you want to do your own, the option is there to implement that interface, which is going to be a GeoEvent processor definition interface, and you can do what you want with it. But why do it when we've already done it for you? So with the processor itself, we have two main, should I say, descriptive stuff that come with the process, or the metadata that comes in. First is an identification, and then the second, the description. So the get label, get description, get contact information, those are stuff that basically deal with the description of your processor definition. Right? And then the rest are supposed to basically do an identification of the processor definition, of the processor itself. All right. So let's go to this particular slide here. And I left out this for a specific, for its own slide, because it's important for us to take a note at what it's doing here. When you have this, you don't necessarily need to overwrite this method to get a GeoEvent definition. The definition itself comes with the GeoEvent that comes in through the processing, right? But if you want to create a new instance, or an instance, if you want to new a GeoEvent definition, you don't want to use the one that is coming in or anything like that, then you can override this method to do that. You don't necessarily need to override this method if you don't have that need for it. That makes sense. So the creation stage is itself for a processor. So we've talked about the processor definition, we've talked about the service. Now we're talking about the processor itself, right? The class that does that. We looked at those three green stuff. So the processor creation lifecycle starts with an instantiation of the processor itself that basically gives you a reference to the definition. And that definition, you call the super constructor and you pass that argument to it. And that basically gets you a reference to your processor that you're working with. Now we look at some things in the background that actually does some of these things. There's other things with OSGI going on, but we'll talk about that later. If any one of you is interested in it, we can talk about it. We want to basically try to limit everything to GeoEvent in this presentation, but there's really cool stuff going on in the background as well. All right, so the next part is the initialization, which is basically trying to get the stuff that the user brought, or the information that the user entered. You want to make sure that they actually meet the information that you want, right? They actually fall within some kind of a specific criteria. So this is where you actually do that. Make sure that those properties work. So if you look at here, you see the validator class and the converter class. Those are kind of helper classes that are within the API that allows you to do some of these things that you probably have to write certain boilerplate code to do. So just take advantage of them and use them. All right, so here is where the validation actually happens. So you overwrite this method to check your validation, or to make sure that the information that has been provided by a user actually meets your set target. And in this case, I'm basically trying to make sure that the user doesn't tell me that the time window is 0 or maybe a negative number, because we don't want to wait on a negative number, or we don't want to wait on nothing at all. And so we go to the key method of every processor, which is the process method, so aptly named. Now, this is where you implement your business logic. This is where you do the stuff that adds the signs of where to the real-time data that is coming in through GeoEvent. So everything from how things are being manipulated and all that, this is where you actually do that. So after that, you have the shutdown or the stop on start service method. You can override them. You don't need to, but if you need to do some kind of cleanup code or cleanup stuff within your implementation, these are some of the key areas to look at. Now, one thing to point out here is that the shutdown method is overridden, and it's not just the shutdown of a service. We're talking about the shutdown of the server, right? So you want to be able to kind of distinguish between that. If you're talking about doing any kind of business logic that kind of takes care of things that you want to do when the service itself is shut down, you want to do with the on service start or on stop or on a service start methods. Those are the areas you want to do that, because the services can be stopped, but not necessarily that the server or the container that actually runs the service that has been stopped. So you just want to take care of that. So this is the configuration file, and does come with as a specification, as a requirement for all your processors, right? And this is where what we call OSGI comes in, and we're not going to go so much into detail on what it does or how it does things, but here what I'm basically doing is that I'm specifying a reference, and that reference is basically built into a container that is basically an implementation of the OSGI specification that is a blueprint container. So those references are actually passed there, and the reference ID that I have there is basically saying that I have an ID of some kind of a service reference, and that service reference is going to be implemented by this the interface, which is the GeoEvent definition. So you provided the fully qualified package and full name for the class, and then you You actually specify, if you have another service reference, you provide that. And then the next key thing is the bean. So the bean itself is kind of managed by the container itself, that is bean manager. And this is where you want to specify the class that actually implements the business logic for the processor. Right. So where the process method is called, this is the service itself is where you're actually specifying this. Right. So once you do that, you specify the properties, and these are properties that you can think of these properties as member variables or some kinds of, let's think about them as member variables within your POJO, right? If you're working with in a normal Java class, these are going to be that. And the way you specify these is that you actually provide these kind of context variables that match the kind of variables or the container-specific variables that are actually part of your service. So if you look here, you can see that the reference is actually a value that is actually pointing to a blueprint context. And then the manager itself is also pointing to a GeoEvent manager service that are actually all being managed by the container itself. So it helps with stuff like inversion of control or dependency injection. So you don't actually have to do all these kinds of things on your own. So once the processor is deployed into the deploy folder, container actually starts with this and calls these and actually news everything for you. So when a component is called by any of the bundles that are in there, it basically supplies an instance of the service to it and says, this is what you want. And once the service is started, if you looked at the method that I talked to you about, that service actually instantiates a definition, and that definition is actually used by the processor to start off. So we can look at the code later on, but for want of time, we just want to look at the snapshots. So we've gone through all that. We've gone through the various intricacies of all these different components that create a service, the processor. And so what could go wrong when you're writing these things, you want to be able to actually figure out what is going wrong when something is not working right. So we're going to just go through a simple demo on how to actually debug your processor. And to do that, I actually wanted to stay safe and not have to deal with the demo guards, and so I recorded a video for all of us. I'm going to go try and walk through the video as we go, talk through the video as we walk. Oh my goodness, I can't find the file. All right, let me do a quick search here and make sure that I can find it and show that. Oops. Okay. Yeah. All right. Do not do this at home. All right. So this is the video that basically. Oh, really? Okay. Let me try.
You need to just
move it. Yeah, I think I got it on here. Good. Sorry about that. Okay. Now let me make it a bit bigger. These things happen. See now, even with a video, the demo guys are not helping. All right. So let's go ahead and try to play the video and walk through that. So the first thing you want to do when you're going to start your debug session is to enable GeoEvent to accept debugging, right? So to do that, you would come to this file, which is located in your GeoEvent install, and it's located in the folder location, the ST folder. So you come to the base install of GeoEvent, you see an etc folder. You go in there, you find a file called the ArcGIS GeoEvent.cfg file, this configuration file. Just open that in your favorite text editor. And on Windows, I think that because of some of these user access rules, you want to open them as an administrator, and so you can actually edit and save the values that you edit. Now, the next thing to look at is that once you have that, you get to the remote debugging session, these parts will all be commented out. In this case, I have them uncommented just so we can have that debug session going. And the part here will be a lettered value, like an N, right? What you want to do is that look at the continuing variable here, number here, and sort of continue the sequence. So here, landed at 14, we continue at 15 and 16. And then just uncomment those lines, save your file, and you'll be ready to go, right? So now I don't think the video is just going to be talking about. Let me go ahead. So once you're done with that, you can come to GeoEvent Server service and just restart it. And once that is done, you can come to your IDE of choice. In this case, we're using IntelliJ. Just like Min showed, you can do this as well in Eclipse if you're comfortable with working with Eclipse. So it doesn't really matter which IDE you use. You can do that anywhere. And then you set your breakpoints. You want to be able to set breakpoints in places of interest. So here we're basically interested in the GeoEvent, the process method. So the first line that comes in there, we're trying to do that. And then you go to, here I'm just trying to show all the other places where the breakpoint is. And then you go to your debug session, which is there, the debug configuration, edit the configuration itself. And if you haven't already done one, you wouldn't see this, but if you want to actually add a new configuration, you add it as a remote configuration, because what you're trying to do here is to debug the GeoEvent processor instance of the container, the JVM that is running the container that you have there. So you connect to it remotely, and then you specify the machine name and then the port number. And this port number actually should match the port number that you actually edited in the file itself. You just don't want to supply the port number that doesn't match. And then go ahead and specify the module. So here's just a single module project that we're working on. If it was a multi-module project, you would want to make sure that you specify the project that contains the processor. So once you click connect or debug, you're going to be connected to your VM, and it's telling you all that information, sweet stuff. So you're now connected to an instance of the JVM that's running your processor. All right. So now let's just take a look at our processor itself and see what it's doing. So this is just a dummy processor, like I said, created for this session, left a bug in there to try to see what things are going. So right now we have a TCP connector, a TCP input, that basically is listening to a TCP endpoint or port for information that is coming in as TCP text. And then I'm basically trying to say, within this time window, I don't want you to do anything, just halt whatever the event that comes in, just throw them away. After that time window, process everything and that comes in, and then that time elapses, go ahead and do that. So I left a kind of a null pointer in there to try to illustrate this issue. So once that is done, you pass it over, and things are still running. So let's just go ahead and go for it. Well, yeah. So here we have an example of a source, a TCP source, right? We connect basically to the input, we specify the configuration parameters, and then we go ahead and connect. So that's the green sign there shows that we're connected to our input, and we're just gonna go ahead and just fire one event through, and then now we should see a debugging session out. Now we've been able to hit our breakpoint. So this is a successful debug or setup of a debug session. So now you're now able to debug your processor just like you would any Java application, examine some of the variables and see where things are going wrong. So like I said, I left a bug in there. So I encourage you to go look at the bug, try to see if that works, and you can use that as an easy way of actually trying to fix. Here, let me see if my guy here will cooperate with me. Okay. All right. So let's try to go through the debug session that we did. You have to open the file, edit the file as an administrator, and just go ahead and continue numbering the GeoEvent schema. This is what you'd find if you open it for the first time, and then you just go ahead and then edit them accordingly, and then remove those comments out. So the next is just showing you just what we went through on the configuration page. Yours might be different, but it doesn't really matter. So you can see here I'm connecting to a remote host, so I provided my IP and all the other good stuff. The argument Java argument remote JVM arguments are not really much, so we can go ahead and ignore them. Okay, so now let's quickly run through what is common amongst all these things that we talked about. We talked about our inputs, we've talked about our processes, both outbound and inbound inputs. Okay. Inbound and outbound input. So let's go ahead and look at that. So the development of both processes, right, and connectors require at least 3 classes. So if you looked here, you looked at processes, you realize that you have 3 classes that basically one does the definition, one does the service itself, and then the other does the processor itself, right? That implements your business logic. All right, and so the processor definition are the same. That is one key thing that we want you to take away from this session, is that you don't really, if you know how to do it for the connectors and you're really good at that, you can actually use that knowledge to abstract into the processes as well. So here you require the config.xml file that kind of helps you with inversion of control, initialization, and stuff like that you can actually use to so you don't have to actually new services in the background. The container does that for you. And like I said, that is something in the background with OSGI that we're doing, and we're using an OSGI implementation. That if you're interested in, we can look at it after the whole presentation. But that is not the focus of this presentation. So and the deployment methods are the same. You finish, you write your jar, you build it with Maven just like Ming did. You have a jar file, and then you just dump the jar file in the deploy folder. Or you can go to the manager UI and just load a local, local processor or connector, or whatever the case may be for you. The key thing here, and I think Ming mentioned it, is that when you're deploying in your Maven file, you want to say that the packaging is a bundle. It's important to actually say it's a bundle because of the OSGI implementation we're working with. If you don't say it's a bundle and you say it's just a normal jar, we're going to work with it all right, but you're not going to have the right localization, so we might not be able to read your strings right. That is quite important to specify. You might not understand why your jar is deployed and everything is seen, but your localized strings are not working. So the nest is about a summary. Let's try to summarize everything that we're going through here, right? So we realize that we have a recipe, a way of bringing data into GeoEvent. The transport we talked about, it bring us the raw data, we're able to get whichever data. We might not have had the insight into what you're doing, so we don't have an out-of-the-box connector for you. But you can actually, without writing any code, you can actually reconfigure some of these connectors that are in there to try to create a custom connector for yourself. And then we also mentioned the processes themselves. So these are GeoEvent implementations that allow you to add that business or the business logic itself, add that value of the science of where to your real-time data and be able to perform some analysis on the fly. And then the fact that we give GeoEvent SDK in addition to the software, you can go through these with samples that are actually in there and go through some of them. There are extensive tutorials on some of these. And then read the developer guide as well. If you have any problems, reach out to us on GeoNet. A team member will respond to you to try to answer your concerns. So next, these are some of the key resources that you might have, in addition to this, to sort of figure out where you want to go next. Introduction data, sort of like tutorials and stuff that are there. So next will be the road ahead presentation tomorrow. That will sort of give an overview of where things are going with the product stack. So please take the time and try to give us some feedback. If I talk too fast, if I rush through something that really wasn't clear to you, I would really, really love that so I can improve on my presentation skills or possibly my English speaking skills. That's about it. So we'll ask for questions now if you guys have any questions for us to answer, either on Ming's presentation or mine presentation, anything that bothers your mind. Yes?
So do you have anything built in to maintain state, like for by track ID or something like that?
Great.
Just whatever we want to do.
Great.
The question is if we have anything that built in that maintains the state. We have something like that in the processors. So you can do an enter and the exit. So it knows that it was outside before it enters, and then it exits. When it was out inside and exits. So yeah, we do have that, but there are limits of the number of events, unique track IDs that you can use in the for those states. But I think it's configurable. You can always change that. If you have a lot of memories, you can change that.
Any more? And like I said, you can also reach out to us after to have an extended discussion if you so choose.
Yeah, we're going to be at Island whole day tomorrow. Yep.
Right, thank you.
Thank you.